The HKU Jockey Club Student Village is a popular choice among HKU students for university accommodation. However, the double rooms they offer have an area of problems experienced by the students, including issues regarding privacy, small space, and ventilation, as well as the inconvenient living experience. As the room is shared by two people, the problem of privacy arises in many aspects. Not only is there no private space in the room when one wants to turn off the air conditioning, make noise, or needs light when the other does not. The preferences of the two occupants may clash, causing discomfort and disagreement between them. Hence, we have designed a plan to improve the double room experience through adding and modifying elements in the room, and the concepts of these methods fall into four main categories: biomimicry, form and movement, role of technology, and sustainability in built forms. The capsule bed was inspired by cocoons and beehives. The bed, fully furnished with personal electronic sockets, lights, and AC, allows to accommodate different preferences on lighting, sound, and AC while sleeping. As the capsule bed has a rigid membrane, it is possible to stack up another capsule bed, allowing the effective use of space. Very little material will be used to make the capsule bed movable so that it allows the customization of the room arrangement. Furthermore, the walls are painted using a paint that mimics the surface of a lotus leaf with close-packed protuberances that repels water and dust particles. This biomimicry helps keep the room clean. A way we are going to integrate free form into the room is through a bumblebee system, which is made of modular storage components and straps. This would be controlled by an integrated in-the-house smart system. This creates a flexible and movable layer of storage capable of vertical movement to fully make use of the high ceiling in the room. Moreover, the room can get very suffocating for students with lack of exposure to the outside environment. This can be solved by controlling the wall facing the outside of the room into floor-to-ceiling windows covered by a series of slats that can be opened and closed under a control button. This will also help control the amount of light being let into the room, which can save electronic usage of the room if used wisely. In the room, there are different electronic systems that we want to incorporate into one technology so that the student easier can manage them all from the same app. The app would have a switch off and on button for AC and light so that the student can do this without having to touch the light switch or use the AC monitor. This is good from a sustainability point of view and convenient for the student. This app would also be gathering information about the user's living patterns and give them feedback about their energy use over the past weeks. Another feature of the app would be a solution for the self-locking doors. Through this app, the student will be able to unlock and lock the door from afar and also open the door through the use of the app. We want the college to have a living green wall on the building. In summer, the wall helps to keep the air cool inside by a process known as evaporation transportation. In winter, this wall acts as an insulation for the room to maintain internal room temperature. The wall helps improve air quality as well as reduce the sound level within the room. Solar panels can be installed to generate energy to improve sustainability as well. They absorb natural sunlight and turn them into energy. It helps in self-sustaining for the room as the energy generated by the panel can be used for the operation of the electronic appliances inside the room. In conclusion, this new double room greatly maximizes the original potential of the room. It uses biomimicry to solve issues of privacy and ventilation, enhances the spatial usage of the room, and makes controlling the room much more convenient throughout technology. These improvements will greatly enhance students' university experience.